Hi everyone. So let's start with our discussion on the Pandas library. If you already don't have the Pandas installed, you can use the pip install panda command to install the Pandas. And it's very interesting and heavily used library in the data analysis fields. So Pandas are mostly used where you have the data in your tabular format, where the data is available either in the rows and columns, and you can do a lot of operation in your data. You can clean it, you can create your data using series data frames. Data frame is heavily used. Again, it's like a Excel like format. So let's start and import our libraries, and we'll start with the series. What are the series here? Series are nothing but the one dimensional array you can think about, and the syntax to load or to create the series is PD. PD is nothing but a pandas alias is a short form, and it's mostly everybody use. They import the pandas using import panda as PD, and all the operation where you will see PD that refers to the pandas. To create the series, we use PD dot series, and we provide the list type of values in it. So let's do this. We'll create our first object, right? And what you see here, these 4, 5, minus 5, 2 are the values, and 0, 1, 2, 3 is nothing but the index. And it also gives us the what is the data type, it's an integer 64-bit, right? And these all the values you can extract separately, like if you want to see what are the index of this series, what you can do, you can call that method, that attribute using the obj dot index, and it will give you what 0 2 1 2 3 means how it is going started. Start with 0, stop at 4, right? Like the range function, the list similarly to that, and step is 1, so it's skipping 1, right? It's incrementing by the 1 value. And how do you see the values here? You can use the obj array, so it will give you the pandas array in 4 5 minus 5 2. Its length is what 4, and data type is nothing but 64, right? And in this case, if you realize we have not given the index value, it was automatically populated by the pandas. But if you want to call it A, B, C, D, something like that, you can definitely do that. And this, in this example, what we are doing, we are creating a new object, object 2, where we are passing the list in these, converting into series with the user base index when A, B, C, D will be available instead of 0, 1, 2, 3, 4. And you can see that your index is nothing but A, B, C, D, right? Whatever we passed here. And what we can do using those index, we can call the value, right? If you the obj2, what it give 4, right? Because a equals to 4. And what I'm doing here is I'm calling this d value, and I'm updating with 6. So you can see the value of d, which supposed earlier the value was 2, now it's been updated to 6. Next, with the index, we can do a lot of operation. In this case, we are selecting the values B and C. So it is nothing but we are combining A with us two values from the obj2 series. You can also do the Boolean like operation, give where obj equals to 0. It will compare the values, each value with 0. So 0 is this 4 is greater than 0, true. Minus 5 is greater than 0, false, like that. And here the D type is Boolean. We can multiply it by 2. So in this case, all the values, whatever is available is just updating with multiply by 2. You can do the exponential from NP from NumPy. We are doing the exponential of all the values, and it's what it returned, and the data by type has been updated to float 64. You can also check whether B is available in object 2. In this case, yes, true, it is available. So in operation is nothing but it will uh, iterate over the series and give you the true and false whether the value is available or not. Let's make the series from the dictionary. So we'll create one dictionary where we are giving the key our Ohio, and this is the value. These are nothing but population data. And what we'll do, we will pass this into pd.series function and give the value as the as data, and that will make the object 3. So this is again the series. So as you can see, the all the key values have been changed to index, and these are the values of the series, right? And you can convert your object back to the dictionary also using the dot to dictionary. So now it's converted back to the dictionary in the same format. Let's create the state list, and what we can do, we will pass this as data, the dictionary here in this series, and states is nothing but the index. So what instead of uh, what we are doing, we are passing this to Ohio, and it will check with the OBG4. So as you can see in the S data, right, there is no California, right? But we are passing in the index. So if value is not available, it will result in NA, not a number, nothing but the null values. And if value is available, it will just pass and check that value and record it here. So these null values, you will see lot of null values NaN in your data. And there is a function called isNA, right, to check whether the value is null. It is null, it will return true, else it will return false. And this is the pandas function. There's you can directly on the object check whether the is NA. And let me change it to 4 to return the same values, right? Same, two different of way of checking the is NA values. So these are the object 3 and object 4, and what we can do a summation. So what it will do, it will check for Ohio and sum it. If value is not available, in this case California is now not available, it will return into NaN. Very interestingly, the we can in this case, you see there is no metadata available, means we don't know what is this, what is this. We can change that. We can make the add the name of this object population and index name as state. And you can see now this represent the states, right? And also its name has been updated to population. We can see what kind of a data set is. If somebody wants the answer, they can definitely see with this information that is the data set of the population in the following state, and these are the values. Now let's move to the next part of data frame. Very important is like a tabular format data structure where data is available in the rows and columns. And in this series, there was like one dimensional, but this data frame can be multi-dimensional, and mostly it is 2D where rows and columns are available. So let's create a dictionary first, right? So in this dictionary, we have a state, year, and populations, right? And it's the same length. So what I'm doing, I'm just converting, giving that value data into the data frame. So as you can see, it's a tabular format. All the key values has been converted into the columns, and these has been populated automatically, and these are the values. So if you want to see the first five, you can always use head. If you want to see the last five values, you can use frame dot tail. Here, what we are doing, we are telling the pandas what columns to be created in which order, right? Year, state, and population first instead of the state. So you can change the columns here and there very easily in the pandas. So let's create the second frame. So in this, what I'm passing the data and the columns. You see the depth, I'm adding a depth column here, but in the data we don't have depth. So what Panda will do, it will create a new column, but it will complete it with NaNs. So no values are available for this, but still it will create the column. How you can select the separate column? So you can use the frame and the square brackets and the name of the column. Also, you can use the dot format in the same dot for, like frame dot, and it will give you the values like the dot, and it will give you the state, right? Same values. There are other another two ways you can extract the .loc and .iloc. What is the difference? LOC always worked with the labels, and .iloc always work with the integer values. So I will show you what is mean by that. So in this case, what we are saying, give me the second value. Second value in the in is what? Uh, so we have Ohio, right, in the second value, and the year is 2, correct? And also, what I will explain this LOC and IOC in coming video. I have a separate code written for that. Also, if in the depth you can see there's any values, right? So you can update in one go. Like if you put it depth equals to 22, it will update for all the values, all the rows for this column as 22. You can do whatever you want, right? Whatever value you want, 1000. Also, if you want to update with the separate, in this case, what I'm doing numpy range so 0 to 5, it will update 0 to 5 values here. And let's check few things. So I'm creating this again one series with this index, and I'm passing those values into the depth. And why it has not updated anything, though we have passed the uh, values, right? 2 3 4. Why it has not updated? Because it checks the index of both, right? It has index 0 to 5, it has 2 4 5 in string format, and that's why if it is not, the value is not compared and equals to the same thing, it is going to update with an. So in this, what I'm trying to do is here is if state is Ohio, means when where the Ohio is, it is true, make it true, and update it in the new column called Eastern. If it is not Ohio, it will update to false, right? Like this. So if you just extract this, if state is nothing but this part, and if it is Ohio, so it will just do a binary, sorry, Boolean comparison and give you the true false. You see the data type is nothing but Boolean. You can delete the columns with the del keywords. Del keywords, your data frame, your column, and it just deleted the you see the eastern column from here. Let's check the nested dictionary. So in this, what we have a key, and it has a sub dictionary in it. So let me run this. So it has Ohio 2000 this value, 1 this value, 2 value, 2 0. So as you can see, there is no 2000 value in the Nevada, and let's convert into the frame, and Nevada don't have the 2 value. What it did, it it took the Ohio and the Nevada and created a column, right? And it took the internal keys and created the index. You can transform this with T, your data frame dot T, like in we did in the NumPy, and it converted your rows into columns and columns into the rows. You can also name your attributes in the data frame like we did in the series frame 3 dot index dot, it will index will be called years and the column will be called the states, like this. Column will be called states and index is called the years, and you can convert into the numpy easily. Index object. So here we are creating the one series, and the index is what ABC. We are checking what is the index here, and with this index you can do certain operations. So give me the index 1, start with 1, right? Means 0 1 2, so it will give you the 1 and 2, right? Index are immutable, so what, let's say we can see what the values are there with the index, but if you want to update the index, it is not possible, it will throw an error. Index does not support mutable operations. So let's create a label. So I'm just creating a numpy 0 1 2 values, all right, and keeping it into the labels, And what I'm doing the creating a series here 1 4 and using those labels, so 0 1 2, so it will give 0 1 2 here and 1 4 2 in the in this column. If you want to check the columns only, so you can use the dot columns, right? And if in operator we have seen in the series, also like in likewise in the data frame, you can use in operation to check whether value is available or not, right? Ohio is available, yes, true. Whether 2 2 3, no. 2 2 0 0 1, true, right? Reindexing, very important. So in this reindexing, what we do, we are creating the index, but let's create one object. So it is DBA, these are the index, these are the values. And what we do, we want to reindex it. We want to create a new index for this, right? Let's do that A, B, C, D, right? And what happened, we have added a new index, but the value is not there. That's why it is filled with NaN. There is a few methods are available. Ffill, which means it will do the forward fill. There is one more backfill. It will do from the bottom up, fill the values. What I mean by fill the value, let's create one series which has the value blue, purple, yellow, and the index is 0, 2, 4. Let's say we want to make it continuous like 0, 1, 2, 3, 4, and we want to fill those values with some data, right? And in this case, we are using the methods, the forward fill. So whatever is there before value, it will just update it. So like in this case, we have added 1, right? And 1 was filled by blue. Then purple, 3 was filled by purple, and 5 was filled by yellow. So let's create a one data frame. It has 9 values reshaped into the 3 3, right? And the index are ABC, the columns are Ohio, Texas, California. And in this, let's reindex. So we want to add A, B here, C, D, and E. So we don't have any values for B and E. That's why it's created the NaN like in the series, right? And we want to add a one more column NY, right? New York. So it will again, the values are not there. It will update with nans. You can use dot .loc which works with the label. So in this, I'm extracting what is mean by this. Give me this row A and C and only the Texas. A and C only for the Texas. You can change to NY. It will only update for NY, right? You can drop the accessories using the like let's first fill the NAs here 10, right? Where the Ohio is there. Give me the Ohio, right? And if NA is there, then fill with 10. So here this value is updated and this value is updated to 10. And you can drop the values using the drop function. Provide the provide the index, and as you can see, the C is being dropped. If you want to drop multiple, so you can let me just run it again, and you can give a list of which index you want to drop in this case C and D. Let's create the data frames one, and let's drop, you can also drop the full column, like in this case sorry, full index. In this case Ohio will drop the Ohio, and in the next we'll drop the columns 2, right? 2 is not available now. Next is what indexing, selection, and filtering. So let's create a one series where in the index is ABCD and start with 0 to 3. It's a float type because the dot is there. And if I remove dot, it will become int 2. Right, let's keep it float only. And I want to get this value, right? So what I will do, I will just keep it B. It will give me 1, 1, 2, 3. So it will give me two values, right? 3, 2, minus 1. Start with uh, 1 0 1 2, and 3 is not included, so it's excluded. If you want to have, you can create a list within the object and it will give you the B and D, right? Index. You can also use 1 and 2. It will give you very similar what we did here, right? And also you can use as I told, LOC always work with the label. So if you can use A and B, it will give you the A and B. On the other hand, the ILOC works on the integer type. So it will create an integer values 0, 1, 2, 3, 4. Like in this case, what we are asking give me 1 and 3, means it will 0, 1 means B and 2 means C. 3 is not included, that's why D is not available. So let's create two object 1, right? 201, object 2, and let extract the from object 1, 120. So it will give you in that same order 120. In the object 2, again, uh, same thing. So as you can see, the object 2 has the index in this string ABC, but still we are passing the values 1 and 2. It is giving like 0, 1 and 2. 0 represent A and 1 represent B and 2 represent C. So in the same order, it is giving back the result. Same, if you try to do the LOC for 0, 1, 2, why it is failing? So it is giving the index because none of the index data types are in the index. So we are trying to extract values in 0, 1, 2, and that's why it is failing using the LOC, because it works, as I told, it works in the label. Okay. On the other hand, if we try to do IOC, it will work because we are using the integer type in the ILOC. That's why it is working. So just understand, if you use .loc, you're working with the labels. If you working with ILOC, it is working in the integer type values into the index. So it is giving B and C, right? Working. Data one, we have this, and if you want to extract the column, you can use this square bracket column name or data frame dot column name, what will work. Right? If you want to extract two columns at the same time, you can create a list inside it, right? 1, 2, 3. What is being 1, 2, 3 here represent? So it represent the index, right? Colorado is 1 and Taha is second. Here we are doing the binary comparison in the data vine 3 in third column, right? Here, if value is greater than 5, return that, right? It is returning all the values which are greater than 5 in 3 column. And you can check all the full data set in data frame. If it is less than 5, it return true, else it will return false. You can use LOC on the columns also if give me the all the values in the New York, right? And IOC2 represent nothing but the index. Again, same thing, 2 and 1. It is giving in the different order because we are asking Otaha first. As you can see, Otaha is second and Colorado is above, but we are asking 2 and 1. That's why the order is written like this. So what will happen in this one if you run this? What we are trying to do here is our in our data frame .loc, we're asking if 3 is equals to 6 updated with 5. What is this is wrong. It's going to throw an error because what Python is saying, a value is trying to be set on a copy of a slice from a data frame. Try using dot row index, row indexer, and column indexer. So what is a row indexer here? This is we are trying to extract raw, and we need to pass the column like in this in the next, and that will update to 5. So the what is we are if the value is 6, right? Colorado is the value of 6. Now we have updated to 5. So that's how we used indexes with the LOC and dot ILOC in both series and data frame. Series and data frame are highly used objects data structure in the Python. We'll continue our pandas. I will create one more video on the pandas. Um, Thank you for now.